All right, in this video we're going to be talking about the earliest start time, which I'll call the EST, as well as critical paths. Now you have the definitions, which really the definitions pretty much, they don't really say much. So the best way to teach this is to go ahead and dive into an example. So from the worksheet from yesterday, you should have had this example where you were taking the entire graph and then you were converting it back to the chart. All right, and so you should have already have done all that, so you should be looking at the same answers that I am. But now what we're going to do is we're going to talk about the EST. All right, now the EST is the earliest start time. All right, so let me give you an example before we dive into this. All right, this is what I've used in the past, and it seemed to have worked to kind of get people to understand earliest start time. So let's say both of these two guys were racing to the car. All right, so the first guy takes off and they decided to both run to the car for some odd reason. And the first guy got there, and let's say it took him 30 seconds. All right. Now, the second guy here, it took him 45 seconds. All right. So we have two guys running to the same destination. Now, here's the thing. I think we can all agree that this guy is going to get to the car first. But here's the problem. The second guy, he's the one with the car keys. There's my car keys right there. So if I was to ask you, based off of this little race, when will the car actually get cranked? You would say it'd get cranked at 45 seconds because the slower guy had the keys. Sure, this guy got here earlier, but he just had to sit around until the slower guy got there. So when you're dealing with EST, you're always dealing with the slower paths. All right. So let's see if any of this makes sense for this guy. All right, now you have start. It takes zero, I'm going to call this minutes. It takes 0 minutes to do start. It's instantaneous. All right, so if we were to ask what is the EST, the earliest start time for task A, you would say 0 because of the fact that it takes 0 minutes to do task or to do the start. And the same thing for B, 0. Okay. Now, let's build on. All right, so let me kind of clean this up a little bit. Did not mean to do that. So, if I was dealing with C here, if A starts at 0 minutes and it takes 2 minutes to do whatever task A is, when can C start? Hopefully you said at 2 minutes. Because what you're doing is you're taking the earliest start time for A, adding it for the time it takes to do task A, to get a running total of 2. All right. Now, let's try B. Let me clean this up a little bit. So B has a earliest start time. I'm going to do this in another color. B has an earliest start time of 0. All right, now I want to do E. It takes 4 minutes to do whatever task B is. So from 0 to 4, E is going to start at 4 minutes. So the EST for E is 4. Okay, now if you haven't gotten it at this point, the numbers that I'm writing above the letters is the earliest time in which they can start. All right, so let's do F real quick. E has an earliest start time of 4. It takes 2 minutes to do whatever task E is, which means F would be 6. So there's my EST for F, is 6. Now, this is where it gets a little complicated. Let's look at D here. D actually has 2 arrows coming at it. All right. So C has an EST of 2 plus 3. Well, that would give you 5. But notice down here, B is at 0. It takes 4 minutes to do whatever task B is. And so B actually has, going this way, actually has 4. So C got there in 5 minutes, B got there in 4 minutes. So the question is, well, what's D's EST? Now, a lot of you guys are going to say, oh, it's 4 because it's the earliest start time. Well, okay, but let me go back to this example. When did the guy, or when did the car actually crank? At the 45-second mark, because that was the slower of the two. Because if you remember from graphing, task D cannot start until both these two get there. So that means B got there first, but C got there second. But remember, D can't start until they're both there. So that means the EST for D is 5. All right, let's go to G. Now G has two arrows pointing to it, so let's see if you can pick up on this. He has an EST of 5. It takes 3 minutes to do whatever task D is, and then D can get there in 8 minutes. But if you notice, F has an EST of 6 plus 1 minute. That can get there at 7. So you're going to take the 8 or 7. Well, hopefully at this point, you know to take the larger number. So that means G will be 8. And lastly, if G is 8, it takes 4 minutes. The finish is 2. Or I'm sorry, 12. So those are the ESTs. So the way that you would figure it out on your chart here, you would say A has an EST of 0, B 0, C is 2, D is 5, E is 4, F is 6, G is 8, and lastly the finish. And now this is referred to as the minimal project time. All right, so let's get back to spell this. So the minimum project time is basically the EST of the finish, and that ends up being 12. All right, let's try another one. Okay. Here's one that's also on your worksheet. So start, once again, 0. So A is going to start at the 0 minute mark. All right. Now this one's a little easier because it's less arrows, I guess. All right. B. Notice A starts at 0. It takes 7 minutes to do whatever task A is, so that means B can get started at minute 7. Well, same thing here. Looking at C, 0, it takes 7 minutes to do whatever task that is, and then C ends up being 7 as well. So both of these are starting at the same time. Now, here we are at E. Now E has 2 arrows pointing at it. So once again, hopefully you can figure this out while I'm explaining it. B has an EST of 7 plus 3, that would give me 10. I'm just going to write off to the side here. But notice that C also has an EST of 7 plus 4, that would be 11. So when does he get started? It's always the last one. Now, let's figure out D, or the longer one, that's what I meant. Looking at 7 to 3, D would be 10. All right, let's look at F. Oh, multiple arrows going to it, so that means we got to investigate both paths. All right, so 10, 1, that would give me 11, or 11, 5, that would give me 16. So the question is, when will F start? At the 11-minute mark or the 16-minute mark? Well, it's the slower one. It'd be 16. All right, let me clean this up. All right, G, we have 2 arrows going into it. So once again, investigate it. 16, 7 is 23. 11, 5 is 16. Well, you know as well as I do, it's going to be the longest one. 23 to 23, 3, that will give me 26. So the minimum project time is 26. So how long does it take to do everything? Well, to do this task using the ESTs, all of it, you'd be done in 26 minutes. All right, I just looked at my clock and it looks like I'm not going to be able to get to critical paths in this video, so we're just going to have to make another one. So, all right, this very last one. All right, start. Remember, you're kind of looking behind. A has an EST of 1. I'm sorry. A has an EST of 0. Sorry. B has an EST of 1. Now, remember, C, 1, or B starts at 1. It takes 1 minute to do task B, so that means C will be 2. E would also be 2. Now, how I'm building it, hopefully you've gotten to this point, is I'm just kind of going to the right. All right, I just keep on just flowing to the right, so to speak. D, if C is 2, if it takes 3 minutes to do task C, D would be 5. E is 1, but oh, look at G. It's got 2 arrows coming to it. D, 5 to 2, that would be 7. Or E, 2, 1, that would be 3. Well, the longest time would be 7. F would be 7. 5 to 2 is 7 versus 2 to 1. And then H here, that would be 7 plus 2 is 9, or 7 plus 5 is 12. Well, H would be 12. And lastly, the finish would be 15. So hopefully you learned something. That's EST. Thank you.